We're doomed, we're saved.
The Biorevolution podcast.
Your hosts, Luise von Stechow
and Andreas Heuchler. We're doomed, we're saved, episode 25. Welcome, Easy, first of all.
Hello.
Today we're meeting in Berlin at the IDA Lab headquarters, and Paul von Bülow is with us, the CEO, mathematician by trade, PhD, and that will prove helpful, I think, for today's episode. Thank you for hosting us today, Paul.
Yeah, it's wonderful to be back on the podcast. A lot has happened in the last 18 months, and I'm really looking forward to chatting with you about this.
Absolutely. Today's episode we called 1.5 years of LLMs, hope, hype, and beware hallucination. I think this needs some explanation, but we'll get to that, and I'm sure we're going to have tons of fun explaining that as well. So, ChatGPT, its brothers and sisters as well, and there are many of those. How do they fare so far? How good are they, especially in the context of biotech, the biorevolution, of course, and pharma? But also, we're going to be talking about the more general approach to large language models as well. And the head start, as always, is a quote, Izzy. What did you bring?
Yes, I brought a couple, so it's a little bit hard to decide, but I will start with one from Rodney Brooks, who is an entrepreneur, but also was at the Computer Science and Artificial Intelligence Lab at MIT, and at Stanford, has some little background in AI, who says, stop confusing performance with competence when it comes to AI. I think we'll get into that for a little bit. And then one quote from Sam Altman from OpenAI, who of course is, maybe not the sole brain, but the CEO behind the brains behind ChatGPT. And what he says, and I think that's something, in the title of the episode and something that will follow us throughout the episode, the thing that I try to caution people about the most is what we call the hallucination problem. The model will confidently state things as if they were facts that are entirely made up.
Wow. Paul, so are we dealing with large language models like ChatGPT on LSD or something, or what's going on? I thought that after ChatGPT has been in the field for a while, that we could rely on the better the prompts are, the better the results are. Are we all proven wrong now, or what's going on?
That's a fantastic question, because I guess if we look back at the great expectations that we probably all had when ChatGPT came out, what has now happened is a little bit, I would say we are in an era of befuddlement. Looking back, the big changes have not happened. The transformative impact in industry is not there. People are not losing their jobs. Even I think the monthly active users of ChatGPT are at least flatlining. Mm-hmm. So what is happening? Mm-hmm. And I think what is happening is that we are just actually at the very beginning of figuring out how to use this technology and how to make it useful.
Izzy, of course, we want to narrow this down to biotech, to pharma, your field of expertise, and we're in a Biorevolution podcast, of course. We're coming to the aid of ChatGPT and others as well, because they are useful as a bottom line. But for what they are useful, this still has to be figured out in a way, right? Is this a correct understanding by my side?
I would say so, yes. And I think, it applies for the general public. How useful are they for any kind of applications of co-pilots, etc., where, you cannot open a program today, right, without it telling you, do you want AI assistants to get this done? It's maybe not.
True.
But the same, of course, is also true for pharma and healthcare and biotech, where the hopes are very big what these models can do. And I think we'll dive into some of the use cases, which some of them are very unique to this type of industry. So I think they have shown hint of usefulness for many things, but we need to figure out in which cases they can become really useful.
Where do we stand in this learning process? How trustworthy can algorithms be at the end of the day? So how far did we get by figuring this out?
Yeah, when we are just looking at this generative AI technology, which is a different matter than explicitly programmed systems, which we can make transparent much easier, then I think what we figured out is essentially that it's not so easy, because the whole hallucination issue is something that that is inherent in the technology, which is a technology that is learning patterns from the past and then it's generating patterns, but there will always be something that is a real pattern that you see in data, but that doesn't make sense in reality. And heuristics have been developed, like for example, semantic entropy is one, but in principle, the other direction where we are also just at the very beginning is how to build user interfaces that really help us to deal with the unreliability.
Do we know anything why ChatGPT and others come around the corner and make this stuff up, hallucinate, as you say? Do we know why it does that?
Yes, it's very clear why that is happening. And it's also something that doesn't come as a surprise to anyone who has built the technology. Because you can conceptually think about this as a big, like, random number generator for text. And if you build such a technology, it's clear that hallucination will be part of the game.
So we have amounts of tolerance. I mean, if I want to generate a Insta post or a Facebook post, I don't care if there's random 5 to 30% or something. When it comes to autonomous driving, very popular example. When it comes to development of medication, of drugs, not so much.
Absolutely not, of course.
Yeah, of course. I mean, that's the big question, right? I mean, in which contexts can we accept error and how much error can we accept for each context, not only in the biomedical field. I mean, you brought up the self-driving cars, of course, but also many other, let's say, finance-related or legal-related fields. If you make a mistake there, it might maybe not kill someone, but it might be very, very expensive to make a mistake, which is also not what you want. And I mean, this is also true for drug development or for any kind of processes that deal with clinical research. Not only does it deal with the safety of human lives, it also deals with the question of putting, 10 or 30 or 300 million of euros at risk, which is not something that you want to do and put in the hands of a potentially untrustworthy system. So I think this is maybe one of the biggest questions that we're dealing with right now, or maybe for me, one of the biggest questions, how to assess this error tolerance and how to put it into a context where we say, okay, this is acceptable for this kind of example, because the problem is if we compare different benchmark studies. So in preparation for this episode, I read quite a few papers that compare large language models with other AI technologies, with human doctors, with amongst each other. And it leaves you, what did you say, Paul, the age of befuddlement? It leaves you very uncertain about the types of results. So I think what we can say is they are better than previous AI systems. In some contexts, some of the large language models that are currently publicly available perform better than others. And we can say when it, for example, comes to diagnosing or getting a diagnosis of a patient, they are worse than human doctors, or let's put it differently, worse than the human doctors that have been used in these studies. Because this is not the gross of all the doctors that exist. This is a very select group of a few experts who are being benchmarked against. So basically, it's very difficult to draw any conclusions. I mean, we have this one area, I think, which gives you some hints of benchmarks, which is test taking. So this is also what, I mean, always makes the big headlines. Now it passed the bar exam, so it can become a lawyer. Now, I think Matt Palm from Google is like close to passing the US medical exam, or maybe now a model already passed it. I'm not sure. But I mean, it's this kind of test taking situation where it might be that the model is able to, within the framework of this test, give the answers.
Coming back to the great quote that you start with in the beginning, is that competence? Probably not.
No, it's massive data, of course. Yeah, yeah, absolutely. I mean, if we talk about the case of autonomous driving, you can also argue if the algorithm doesn't recognize a tree and the car in not so much speed rams the tree, okay, we have traffic jams, we have accidents all the time. So, and you mentioned the doctors. I mean, if there's a doctor in the countryside who doesn't, doesn't do further education, for instance, and left the academic field 25 years ago and still does the same diagnosis he did 25 years ago, tough luck. The algorithm is going to be better, I think, right?
And the algorithm has infinite time. For the doctor, it's just, the amount of time that you spend on a single patient might just not be enough to derive the diagnosis, versus a tool that just has the data of the internet or the data of all medical records or scientific literature or whatever you want to put in at its demand can, of course, draw different conclusions than a human doctor.
So how do we develop use cases around all we have as an entry set by now? Where do we need to adjust? Do we need to adjust in the framework and the regulation much more than in the algorithms themselves, where we can build on with human brains from then on? Or do we have to define those rooms basically to get to a good working system where less error is happening? Or do we need to work on the algorithms more? I simply don't know where to start there.
And I think there are probably answers on different levels that all need to happen in parallel. So I think the first thing we need to look at is maybe, are we working on the right types of use cases? So as Louise already mentioned, it's a different thing whether you want to improve the top end, like the best doctors, or if you want to have something that raises the average, or maybe even just pushes the low end up, right? And then it might be that probably use cases that are more around like the low end of some cognitive work, which could be medical, which could be legal, which could be advisory in other areas. That's probably maybe more the area that we should target. That's the one thing. The second thing is then, what's the amount of error tolerance that we have, and how costly is it to deal with errors? Not only in terms of risk, because there are also some errors where there is no real big risk. Like think about like a travel advisory service. Nothing can really go wrong. But still, we maybe more have the question of, is it actually useful? Like how long does it take to check for correctness? If that check takes as long as you would do the work yourself, it doesn't make sense at all. Because there is this quite good like mental image by Ben Evans. And he says like, imagine you have infinite interns. What product can you build out of these interns? And then the last part, and that's maybe the product question.
ChatGPT, by the way, will be very, very, very unhappy to be called intern.
Well,
PhD level intelligence.
That is true. And then like maybe more on the product side, like how do we wrap these large language models into something that we can use? I think it's important to remember that ChatGPT was a great demo interface. So it was a fantastic sales tool, which really illustrated the potential, but also in a misleading way of this technology. But in many areas, you don't want to chat. Like how often do you want to chat with a website? You typically only want to chat with a website when something goes wrong. You didn't get your Amazon package. Sure. You can't find something on the website because other types of interfaces are more useful. And here the interface question is, I guess, particularly important because we need some interfaces that allow us to gauge like how reliable is this information that I'm getting and what do I do with it? And I think it's interesting to see that Apple, for example, has been very cautious around embracing LLM technology. And they are now maybe taking more of like a second mover approach, which in the end is probably the better one.
By the way, what has changed between 3.5 ChatGPT and 4 for you in your world?
In my world, very little, to be honest.
Okay.
In my world, I'm using it also just as a user, and it works much better. And there is this hack, now I'm giving a prompt hack advice, yay, that if you tell it, reflect on each line before you answer. So for each point, think about what you say, which doesn't make sense. I know it's a machine. It does not think, but it still gives better answers. I tried that for filling out tables. It's much better. It reduces a little bit the hallucination. I just wanted to come back. I have to say it. I heard on a recent panel discussion on the role of AI in the public sector. They brought up a case of Air Canada who used chatbot to make bookings, which gave the customers offers that didn't exist. And now they're in a legal dispute with exactly the question of liability. So is it the fault of the chatbot or the fault of the airline? Because they're saying, yeah, we didn't offer it, the chatbot offered it.
Let's try to talk about the evolving scenery with the hallucination case and ultra low tolerance. in medical, in pharma use cases. Is there any way to use again algorithms for the control instances in any thinkable world?
Maybe I start from the more user-centric view and then I hand over towards the more mathematical side of things. But I mean, there is really the way you design prompts can reduce the hallucination to a large extent, but it does not make the model better, but it helps you restrict the answers and then also having limitations in the types of data that you put in. So not making the inference or the decisions or whatever the model is doing on the whole internet, but on a limited body of text. That said, of course, it has the implicit knowledge of, I mean, depending on which model you use, but if you, for example, customize GPT-4 or whatever, it will still have this implicit knowledge, and you don't know how much of this ingested text it uses to, again, make up things. So I think these, for me, as a not builder of products, but as a user of existing models, would be the things or the way to reduce the hallucination.
And by the way, do you think that we may or might use algorithms to find and create the good prompts?
I don't know, actually. I think that it's not, so what I understood is that it's not good to use more machine-generated text to make the machine better. I think it just makes it worse, or it doesn't improve.
On the one hand, like these strategies that you've mentioned around prompting or using LLMs in a way that makes hallucination less likely. And then there's, of course, the other type of remedy. How can we detect hallucinations? For example, to show like some of the output maybe in red so that you know, okay, this is something that you shouldn't trust. And one of the things that's currently like very hot, and I think that has just also been a recent Nature paper, is this concept of semantic entropy, which of course sounds wonderful, very cool.
It does.
But the idea is very simple and it's also not so powerful, but it's a great heuristic. So essentially what you do is you ask the LLM several times the same question. And every time you will get back a slightly different answer, in particular if you tune the LLM a little bit more to sample a bit more randomly in the potential space of answers. And then you take all of these answers together, and this is where the mathematicians get very excited. Then you don't compare them directly to each other, because that would be stupid, of course. You map them into like a semantic space, so a space of meaning. And then in the space of meaning, you see how many clusters are there. And if there are many different clusters, then many different types of answers with different meanings are in the response. And then, you know, this is an area where maybe you shouldn't really work with the LLM.
I also have to say, I mean, there is the same issue around AlphaFold, right? I mean, it's a completely different model. It doesn't do the same thing, but it also has this problem of areas of low confidence. So it can tell you this prediction of the protein structure is not trustworthy. But I mean, it's nice to know, don't work with that, but it's also only, it has limited helpfulness, let's say.
Yeah, absolutely. I mean, there's no way you can solve this. You can only just stop using it. And it also just very nicely shows what these models are. They are pattern generation machines trained on data.
Yeah.
And if there is no data in the vicinity of what you've asked, you will just get something.
Yeah. Of course, that also refers to AI itself, because, you know, recently I've been talking to Greg Wheeler. He's a philosopher and AI professor. He's one of the people engaging in groups who try to pose this basic question: how can AI do with less data and more quality? I mean, this approach is not fairly new. It's been in the field for a while now, but this is a point where it gets interesting for AI in itself to develop not only LLMs, but very much so they too, right?
Absolutely. So, I mean, that's like a general issue with all machine learning systems that essentially just learn from data. Because we always talk about these models as models, and they are mathematical models, but a philosopher would probably say they are not a model, because there is no causal mechanics that we infer, etc. These things are often black boxes, and there is very little in terms of like epistemology or whatever. So the big next frontier is, as you've said, combining symbolic AI, which means like bringing in real knowledge that we have around the world, and combining that with something that we learn from data and making these two things work together. But there we are at the very beginning. But that's super exciting.
And I think this is one of the big challenges, as you mentioned, with the large language models, because they give this semblance that they have knowledge of the world, and they don't. But they make you believe, and I mean, the way I just talked about it is like super anthropomorphizing. I mean, it's exactly that. You think the model understands the world because it gives this semblance of text understanding, and you feel like, but it must understand more than it does, and it doesn't. It doesn't understand anything. It just memorizes things that could work in a context, but it doesn't have meaning behind it.
I think we now need to come to the defense of LLMs a little bit.
Yeah,
right?
of course. Yeah. I mean, we're not trashing them at all.
No.
We love them.
I mean, the name of the podcast is, after all, We're Doomed, We're Saved. So we had some characteristics of doomsday, but also the promise of what is yet to come, which I personally think is spectacular once we get there, to combine the two worlds. I think we have to talk about text-related stuff where really LLMs can be useful, not in a sense of firing zillion people, but in a sense to make initial sense to build on, right?
Yeah.
So, I mean, what really amazed me, and this is an area where LLMs have really gone way beyond my initial expectations, is how well you can use them as like text and grammar understander for like narrow questions, getting some super important pieces of information out of large bodies of text. And there are like really important use cases, I think, in the biopharma industry.
Yeah, absolutely. And I think that's, I mean, also what people are using it for already and productifying it around that. So, I mean, what you can do with it, I mean, just excavating information from these massive bodies of text that you have in pharma and in biotech and in healthcare. I mean, you have the scientific literature, you have the patient notes that doctors take, and you have everything in between. You have like pieces of text that are in lab journals, in investigators' brochures, even in chats between employees of a company. I mean, you have so many bodies of relevant text evidence that you could use and extract, I mean, limiting to a certain body of text and then extracting meaningful informations. And I think also contexts from these bodies of texts work really, really well. So, for example, saying like in a very simple context, is this drug related to this disease? This, I think, works. What I think doesn't work, I mean, Paul, correct me if I'm wrong, but what if you would say, which are all the possible drugs that might work in this disease? Because this, it cannot do. It can only do like more specific questions currently.
Even very simple things like patient data management, for instance, which is still vastly unorganized, unstructured. And so I guess LLMs do make perfect sense. A leading doctor who has funds by the European Union trying to cross-examine the extent to which Corona hit in Europe and trying to find out why did it hit less in Croatia than in Germany, for instance. Of course, this is comparing data in a rapid mode, and this is useful. I mean, there will be a margin of error there too, and you still have to check it and double check it and triple check it. But from the get-go, it does make sense, a lot of sense, right?
And there is the chance to have the so-called virtuous cycle, so the opposite of the vicious cycle, because, I mean, by standardizing data more, especially when it comes to this whole healthcare field, where you could just use LLMs to, for example, have a recorded conversation between a doctor and a patient, and not only put that into writing, but also there's a lot of like bureaucracy around that, which I think the large language models are pretty good at. And I mean, it could not only save time, but it could also, again, make those types of data more machine readable. So you can do the types of research that you, for example, just mentioned on them. And that would, of course, be really, really helpful to do and would, I mean, and that's always the big promise, save the doctor time to do something else, which could be spending time with a patient or reading something meaningful, or maybe also, I mean, many doctors are extremely overworked, so they could maybe just rest a little bit more, and then, but that could be nice. Or
other medical experts as well, not only the doctors, of course. Yeah, absolutely. Where do we stand in data protection in Europe versus the US? I mean, this is down the beaten path. We've talked about this a zillion times, of course, but still, my feeling is that it still needs to be some movement to come to a solution. Just a quick sentence about that.
Yeah, I mean, I guess we are all also now have found like pragmatic strategies to work around these limitations and work within them. And I would say probably for applications of large language models, when we are trying to structure big bodies of text, there are many use cases where we are not dealing with personal data. So GDPR is out of the question.
And if it is, I mean, there is still, I mean, it's the same as for any kind of applications that deal with patient data. I mean, we anyways need to figure this out.
Yeah, and we can anonymize stuff as well.
I mean, the question around this is if the model takes it into its implicit learning. That would be the worry that some people have.
Maybe one other area we could briefly talk about where we already now see really a lot of real impact of LLMs. Beyond this extracting information from text, I think is the other area of like exploring very quickly a large option space in a slightly better way than we could do before. Applying LLMs not just to human text, but to DNA to generate potentially new proteins. I think that's a super interesting area.
Yeah, that's for me, I said it in the last time we spoke about it as well, that's by far the most interesting, the most exciting area that I can think about to apply this, because you said we want to not trash talk the LLMs, but I will say, I mean, you still sometimes feel it's like a glorified Google search, which it isn't. It's much, much, much better and complex than that, but still. But for this kind of application, I think there is the chance to create something new that humans cannot create because they cannot read the molecular language. And the LLMs can, to a certain extent, have, again, I say understanding. I don't mean understanding. They have a memorization capacity to familiarize themselves with the languages of molecules. And that can be, of course, the code of DNA, 3 billion sequences, I think, the human genome, which consists just of 4 letters. So it's really like a binary code, basically. And then we have proteins, which are made up of 20 amino acids. And then we have also chemical molecules, which can be read in this so-called SMILES language that basically linearizes chemical molecules. And apparently the LLMs, especially I think for DNA language, seem to be pretty good at learning this language. And of course for human, I mean, you can sit there and read A, G, C, T, 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 but it will not tell you anything. And also, right. I mean, I know some like academic researchers who look at a sequence of DNA and say like, yeah, but here is the promoter. I don't. But of course, the large language model, given that it can process so much information, can do that. And this is
fascinating.
For me, still super exciting, I have to say.
Do you think LLMs hallucinate less when it comes to molecular language, or is it just the same?
I would say it's just the same. I think it's just really the problem of the model. I also don't know if they hallucinate more. I actually don't know. It's a good question. I would not be able to answer that right now. I think the language is a little bit different. I mean, the human language is more structurally implicit through the grammar. And the molecular language has some other factors. So, I mean, we have this sequence of DNA, but there's also structural information entailed in this sequence. And this, the model doesn't know, or probably does not know, very likely does not know implicitly what, on the one hand, I mean, within this sequence of DNA, it tells how the DNA itself folds, because the DNA itself is also not lying around flatly. It's like a really complex molecule. I mean, it's really coiled and wound around proteins and doing a lot of stuff. And this also is important for the regulation of the DNA, because bringing 2 sequences that might be very dispersed together will lead to their activation. And then it also holds the information for how the RNA that is based on that will fold, and the proteins that are based on that. So basically you have 3 levels of structural information within this sequence that we don't understand. And this is, I mean, that was the big question, right, around AlphaFold, which was this huge success for DeepMind, where they said they solved the protein folding problem. It's super good, but they didn't solve the protein folding problem because we still don't know which sequence will fold into what. It's again just memorizing a lot of data and then getting very close to predicting the right thing. But it it does not have the knowledge of the world, of the DNA.
I just wanted to add a completely unrelated thought, but it's related to hallucination. So I was just wondering in which area probably would we maybe not have an hallucination issue at all? And maybe that's music, because it's art. And what is wrong in music?
I mean, that brings us also back to which doctor do you benchmark it to? What is wrong? Because, I mean, humans also make mistakes and we say wrong things. Is that a hallucination, or is it just, I mean, our brain also autocomplete stuff, and a lot of the things that we come up with, I mean, sometimes you also just use the wrong word, but also sometimes you just, produce information that's simply not true because you memorized it wrong, or because you have strange ideas about the world or whatever. And then, I mean, we don't call that hallucination, right? So it's also a question, I mean, as you say, of context, what we call right and wrong.
Absolutely. Fascinating example with music.
And I also want to add to that very quickly. I know we're running a little bit over time, but one really big point of criticism for LLMs at the moment is that they are just flooding the internet with useless information, or text that no one wants to read, and images that have people with 8 fingers and I don't know what. And I think here it's also really, and I mean, people complain about wrong information or wrong content. And there is really, I mean, who gets to decide? I mean, who gets to sit down and say this is harmful or wrong or bad information that the LLM generates? And if the same information would be generated by a human, it would probably not be counted that. I think that's a really, I mean, it goes deep into philosophical questions, but I mean, this is what we have now because the model is there and it's producing all this content.
Yeah, and the internet is as open as it is, of course. Yeah.
So now we just have all the shitty content.
Yeah.
Oh no, now we have to put an E to the episode, sorry.
The bulldozer, are LLMs even technology?
I would hand that over to Paul.
Yeah, it's of course a question that I love to think about, because we've been working a lot with LLMs over the last 18 months, and we've been able to do quite a lot of really amazing, useful things. But the way we worked with this technology was fundamentally different to any other technology that we've ever worked with, because there is this new emerging role or discipline of prompt engineering. But I think engineering here is quite a euphemism. When you watch a prompt engineer do his or her work, you see just a lot of trial and error, a lot of frustration, and there is a lot of tricks of the trade and magic, and nobody knows when stuff works. And that's not a good property of a technology. And it may not even be technology according to the textbook definition, where we say, it's a scientific, reproducible, rigorous application of an approach to solve problems. And somehow the real projects around LLMs, they don't really look like that. And maybe it's also not surprising when you look at conceptually what an LLM is. Because an LLM is this huge probabilistic model where essentially, simplifying of course, everything is connected to everything else. That's the definition of complexity. And the implication of that is that it's very hard to modularize it and say, here's the engine, there is the gearbox, there is this, and I can take things apart, I can test them separately, I can improve them separately. That's where we would like to get with LLMs, but the last 18 months haven't really brought us much closer. That's why maybe it's something else.
Is it magic? If it's not technology.
Unfortunately, it's neither magic.
Are we hearing the voices?
Are we hallucinating?
But then on the other hand, I don't know, I wasn't there when the first combustion engine was built.
Right.
Because that is also a technology where a lot of things, like their chemical processes, their physical processes, and you also have this complexity, and it took a long time to tame them.
Yeah. And I maybe would like to add from the point of view of a biologist and not an engineer or mathematician. I think I'm quite comfortable with stochastics and with fuzzy data and with could be that or could be that, because there is so much uncertainty about biology. I mean, also the way evolution works, but also the way cellular systems are made up, buffered, and you take something out and it might be completely different on a small, cellular scale, but also on the scale of ecosystems where you put in a new species or you take one out and you basically cannot predict what's going to happen. And therefore, for me, this is I don't know, I don't feel very negative about this uncertainty and stochasticity of these models. I find it also fascinating because it feels like, it feels very close to home for me.
I think it's absolutely fascinating. I think the big question is it similar to biology, where if you really apply science to it, you can find the patterns. And you also can find the modularization. I mean, that a big organism consists of cells. I mean, that is an organizing principle, which in itself makes things decomposable, understandable. You can analyze them, you can break them apart. Is it like that? Or have we just built something in a way that makes it through this transformer architecture where you have these long-range correlations zigzagging in the model and connecting everything? Have we maybe built a box that we will never be able to look inside? I don't know.
Many thanks, Paul. Many thanks, Easy.
Thank you.
It was a pleasure.
I think on this breathtaking LLM journey, we have to meet again like soon-ish, right?
Yeah, I think so. But it might also be that we have reached the ceiling and that they will, at least from this getting better and better and better at the tasks that they do, that they will not now, within this frame of GPT 3 to 4 getting massively better, that this might not happen again, even though they promised PhD level intelligence for the next rendition. But I think what will happen is that we'll find probably better use cases or we'll know where to use it. And this will be really interesting to follow up. And also I think the key question is, how do we evaluate those things? Because at the moment, as Paul said, we don't even know what the parts of the system are, so we don't know how to understand why it works or why it doesn't work. So it gets back to this level of magic, just tinkering with things and hoping. That sounds very bad now because I think we know much more, and we also know applying certain strategies for prompting or for data restriction or what you say heuristics that lead us to a better understanding of the model. The problem is we can still not look inside the model, and this is the real challenge, because if things then still don't work, we will never know why.
And we humans, we love causality.
Are we going to be looking into the box or not? That's a big question. And I think it's just fascinating. This was We're Doomed, We're Saved, episode number 25. Many thanks for listening. If you like the show, please subscribe to it. And further reading recommended at sciencetales.com. See you next time around with episode 26. Easy, do we know what we're going to do?
Yeah, we'll talk about what it takes to realize the future of medicine. So really small topic.
Very, tiny topic. We'll need like 15 minutes or so for that.
Yeah, I think that will be fine.
Thanks again for listening. Thank you.